Hello, everyone. My name is Hassan Aziz. Actually, I'm here to kind of talk about the Evenstar contribution that was made to OCP by Meta. And we're part of XR Communications. We're a new startup that's supporting the work that was contributed by Meta. So before I start, a little bit of intro about ourselves. XRComm is a startup formed in February of this year by former members from Meta, the original Evenstar team that was responsible for the radio design, especially in the O-RAN space, along with additional activities that we have been supporting in the ecosystem for silicon and DU designs for Open RAN. So XRComm is formed by former members of Meta, Evenstar team. We have expertise in wireless communication systems design with emphasis on physical layer, algorithm development, both for transmit receive, especially with massive MIMO, with beamforming. We have expertise in algorithm development, RF and digital design, and architectures for radios and DUs. Also, we have a very strong, members of the team who have been doing standards contributions and been delegates for 3GPP and Open RAN for a long period of time. So just to kind of put it in the perspective of what a typical, RAN network looks like, and what does it mean from the Meta's contribution on OCP. So as you can see in this picture, essentially there's a radio part and there's a DU part, and then there's the CU and the core network. So primarily, like, the strength of XRComm is actually on the RU and on the DU part of things. And the contribution that Meta made is actually on the radio piece. So the idea here is that Meta has contributed a design, a very modular design, which I will go over in the short period of time, that will discuss sort of what that contribution is about. But you can see, like, in the same edge booth that we have the Intel DU part of it as well. So in the long term, like, we're looking to I guess from an OCP perspective, in the telco side, they're actually trying to promote the idea of having more of the components of the RAN network, of the RAN, so that the end-to-end system can be built in a very similar way. Right now, the data centers are built with open source solutions. So moving forward, like, what is the contribution that Meta made? What does it include? So the part that's actually there, you can see the radio design. We have it in our booth actually, with all the boards brought out. It covers the filter design, and there's some uniqueness that we have actually. We'll go over that. We have a power system unit, the digital modules, also the cavity filters, the PA modules, the mechanical design. And from an algorithm perspective, for those of you who have been in this radio world, you definitely know the DPD and CFR and PIM cancellations are very important piece of the puzzle for these radios. Also, Meta had contributed, some test scripts that cover massive MIMO. Now, where we fit in XRComm is actually we were part of the original design team that did the radio design, did the whole MIMO test solution and everything. And when Meta ended the Evenstar program, some of the members from the original team, we actually decided to kind of form a startup and continue this effort, as there has been a lot of interest both from the operator side, OEM side, and even the silicon vendors. So our mission is to kind of carry this forward and work with OCP moving forward. So here's the part of the design that's covered in here is very modular. So the main thing that is achieved through this design is actually, because in the typical radio space, you have to support multiple bands. You have to support multiple radio streams. Like, you need to go from 2x2 to 4x4 to 8x8 and even 64 TRX. And so this is a modular design. From the beginning, we had this concept that you should be able to do modularized design, and you should be able to kind of extend these designs. So this is a key factor, and if you stop by, you can explain how this is done. Also, one of the challenges that was put out essentially by Vodafone also was that build a radio that's in a BOM cost for a single band radio under $1,000 that performs equivalently well for any of the incumbent solutions. So this is actually one of the key driving factor design constraints. Of course, there's the weight and the power and the size and the cooling and all of that, and we'll go over that a little bit later. So here's sort of a breakout of the boards, and you can see like how the modularity is brought in, and you can see some of the filter designs that Meta had done. We did during the time at Meta, and a typical air cavity filter is about this size, and you can see the size reduction and the weight reduction on this. So there's a number of things, and the same thing, like if you go into the PA, there's the aluminum pallets that are used in order to do better heat dissipation, which really actually reduces the weight again overall and improves the performance of the components. Very similarly, we have a PSU, the power supply unit design, that's actually over there, which really is built under a $100 BOM cost and really performs very well at 95% plus efficiency. And you can see like some numbers here in terms of the filter itself. A typical traditional filter is about 3.7 liter, whereas this new filter is 0.8 liters. So significant reduction in size and weight. And so this is actually open right now for the community to leverage these kind of great innovations and move that into their product stream. Now, same thing like on the macro, like on the digital board, it has also been modularized. So now if someone wants to take the Xilinx design and use it, that's what we have. That's one option. Of course, there's an option from Intel and several other vendors. And so these different combinations can actually be done through this, keeping the similar radio architecture. And I'm going to skip this slide. So now, in terms of what's next, right? So we're basically supporting this initiative from a new company's perspective, from a startup's perspective, from XRComm. We have design supports because we are the original designers of this radio that will be working with the community to help. We have test capabilities that are very advanced. We have both ORAN and 3GPP conformance test capabilities. We have ability to do multi-vendor IoT, which is a very important piece for all ORAN work. And then we have a state-of-the-art lab to actually do this work. And different things to consider in terms of consulting areas where we can help, mechanical thermal, also the extension from 4x4 to 8x8, FDD and TDD bands, extension to support of 1024 QAM modulation. For FDD, there's all the algorithms necessary to do PIM cancellation. We can help in terms of the power consumption reduction with different sleep modes supported. That's built into the design of the hardware. And the DPD CFR algorithms optimization. We have a tremendous amount of areas in signal processing in DSP that we can provide a lot of support in addition to RF. Now, in terms of the conformance test, there's a number of things. Like our lab is multi-vendor. It's not a Keysight lab or a Spirent lab or a Viavi lab or anything. What the objective was to kind of build a best-in-class lab capability to help with this whole ORAN ecosystem. And we combine all the the best-in-class equipment from all the vendors to really achieve this goal. And one of the strong points that we have, and this is actually some of the setups that we have for doing the conformance testing in our lab. Again, this is for the ORAN automation test that we have in order to do this. So you have 3GPP conformance test, you have ORAN conformance test. And a very unique setup that we have, actually, I would say, like in our lab, is actually the ability to do massive MIMO beam-based test. And a lot of the work that has been done in the past, of course there's conformance part of it, but the real differentiator is actually the performance of your massive MIMO designs in actual, as you're doing beamforming, beam tracking, beam quality and all of that stuff. So we have very unique setups to test up to 64 TRX with emulated mobility of UEs and so on. So what's next from here? I think as the big question that I guess that's on everyone's mind is that we identify, like ORAN has been very active in taking this design, and they have been working with the different partners at OCP to identify the target markets and interests. And the Evenstar contribution serves as a starting point to enable this work. And then the standardization and harmonization will happen between all the OCP hardware piece along with the ORAN part of it and the tip. So these are like a number of items that OCP is going to be working on in the coming days and months. And I think the idea is that to do exactly the same thing as has been done on the data center side, to bring the same sort of modularity and spirit into the telco industry. And from our standpoint as an XRComm, we're here to provide any support needed for any of the vendors who are willing or interested in adopting the design and or variants of it. And we're also able to do any kind of comparison tests that you want to run with your current solutions versus the parts that you want to adopt and so on. So with that, I'm going to end my talk, and thank you for attending. Please feel free to stop by in our booth, and we'll give you more details on specific components of your interest. Thank you.